All right, we are here at NVIDIA GTC. We just had a big announcement with Voxel here. My name is Helda. I'm the head of physical AI at Nebius. And we're here to talk about what we announced, why it matters, and talk about what you guys built. So, Dan, before we get into the details, give us a little background on Voxel51, why it exists.
Yeah, absolutely. So Voxel51 is a data platform for physical AI to help build out the best models possible, really, by starting with the data problem. Voxel51 sits at that data level to help you make sure that you can find that data is going to drive your models to the best performance possible. That's things like finding outliers in your data, evaluating your models, and really nailing down exactly what that curation problem looks like to find those samples in your data set that's going to drive that model performance to the possible limits you can possibly go to.
Love it. So one of the problems with data curation and driving model performance is that you don't always have the edge cases.
Right.
There's so much long tail information that happens out in the real world, different kinds of weather, different objects in a scene that you could never plan for, recreate in the physical world. And so I think that's the main problem we're trying to solve. So talk to us a little bit about how you guys think about filling in those gaps along the long tail, and then from there we'll go into the solution we built.
Yeah, absolutely, right? It's kind of hard to contextualize sometimes. We're always looking for the 1 in a million cases, especially in things like robotics or self-driving, but what a lot of people don't realize is 1 in a million actually becomes pretty common over time whenever there's so many different 1 in a millions you're trying to encounter for, whether it's random things like people jaywalking, weather events, we're thinking things like snowy days at night, right? There's all these random events that could happen. So we're trying to first find out how well our model does during all these events, and then, well, if I found one of these events that my model performs poorly on, whether I mentioned in robotics or really any physical AI field, how could I now find all the other events like that in my data set, right? Do I have that many? Or in some cases, as you mentioned, we don't have any of them, right? So how do we tackle these problems and making sure that our robot or our car performs the safest action, even if it's never seen that before, right? And that's where really synthetic data is crucial into like closing the loop to make sure that these cases are solved.
I love it. So behind the scenes of the solution you built, there were two main NVIDIA primitives we used to build that. We used NVIDIA Osmo, which is the orchestration framework to move data and workloads between disparate compute environments. And then we used the NVIDIA Cosmos world model.
Right.
That's what we used to augment and multiply data and also do some quality controls on that data. Talk about how you guys thought about Osmo, Cosmo, and how what we pulled together made it really easy for you guys to quickly integrate. And then from there, get into how you guys have turned that into a product.
Absolutely, right? And I mean, what a breeze it was to really integrate it. I mean, the experience with Osmo and Nebius was really way easier than I could ever imagine to get started with. And what Osmo allows you to do is really scale this up past a lab project, right? A lot of these things are being done by a lot of companies. They're investigating whether they should do it for their production use cases, but it never really leaves that kind of lab, experiment, prototype world. With Osmo, you can really scale this up across multiple different GPUs, across different clusters, start jobs, rerun jobs, test new things out, which, using the Osmo APIs becomes much easier. Once you tie that into the NVIDIA Cosmos models, I mean, you can really get up and running on a synthetic data pipeline way faster than you could ever imagine, right? We tie that in with the Voxel51 platform, where it's all about data curation, evaluating, making these crucial decisions about what the next recipe has to be, what synthetic data generation is the best thing to move forward to, and evaluating, hey, are any of these hallucinated? Is it safe to add to my data set? Are the crucial questions that were being evaluated inside this Voxel51 tool? Tie into the fact that all of this is done now agentically by tying in things like Nemotron and other data agents that are sitting inside of both your data set as well as in Nebius to really make this a much more efficient process. From what we were doing synthetic data a year ago, I mean, it's probably 100x from what we were doing by the combination of our tools.
Totally. Can you draw a contrast for people who might just want to pull Cosmos off of a marketplace or off of a repo? Draw a contrast between what they would have to do to actually make it work for them, and contrast it with what you guys did. Because I saw on your platform, you guys have all these like knobs you can tune and turn. You guys have a prompting area to help with like creating a better output. Can you draw that contrast between like off the shelf versus
absolutely
new world?
That's where the data agents are so crucial, right?
Okay.
Right now, when you pull a Cosmos model right off the top, you have to prompt individually, not just per video, but per augmentation of that video you want to make.
Wow.
These prompts need to be razor sharp. So I mean, you're spending time saying things like, I'm driving down the street and it's a snowy day. Then I got to delete that. I'm driving down the street and it's a rainy day. You have to do this for every single one of the videos you want to do this. It becomes a near impossible task for one individual to write all these prompts for every video. It just doesn't scale. What we've built together and what Voxel51 allows you to do is you can define distributions that you're interested in. I want 30% of my day to be rainy, 30% of my videos to be snowy, 30% of my videos to be foggy. This allows you to build up the distributions and build your own custom recipes for your robotic use cases, your AV use cases, any physical AI use case. And then the data agents that are sitting inside of Nebius will help auto-create these prompts for you with VLMs that are tested and ran inside of Voxel51, backed by the Nebius compute, that now I can really just say, make it snowy, something as simple as an English language like that, and scale this across thousands of videos that will now be augmented and then be pushed to our production data set afterwards.
Amazing. You guys built this all in weeks.
Yeah.
So I can imagine where this can go. So as we wrap here, let's look into the future.
Right.
You guys have been historically very much focused on the AV space, video data, but you have ambitions to get into robotics.
Absolutely.
Speaking of the devil.
Yes, this guy right here.
He knew we were getting into the topic.
Yeah.
So as you think about how you're going to get him to be smarter and do more than just boxing, where's Voxel heading in the future here?
So now we're thinking about the full scale of physical AI, and there's many different fields that might include. We're thinking things like robotics, but we're also thinking about healthcare. We're thinking about smart cities. We're thinking about drones, the federal space, right? Expanding to all these places that can take in the latest and greatest of physical AI. And this Osmo recipe for using Cosmos world models is only the first Osmo recipe we're going to build with Nebius, right? We're going to move to things like digital twinning, cloning full cities to allow you to run closed loop simulations, procedural world models, and every type of other physical AI, VLA training that we can build in to make it an even easier experience for people to actually get this stuff up and running, use the latest and greatest, and scale it out using agents without having to be an expert about every single part of the loop, right? We want these people building robots, building their drones for the future, and spending time doing the real ML work and leave the infrastructure and the data to us.
More robot learning, less infrastructure toiling.
Right. Exactly.
How about that? I'm gonna
coin that one.
I'm gonna keep
put
that
it
one
on a t-shirt, you know?
All right, we'll use that one for next year. Well, much more to come from our partnership.
Absolutely.
We're gonna help you guys build all that. I'm excited to showcase it next year at GTC. So thanks for the time, and we'll see
it's a
everyone
pleasure.
next year.
Yeah, see you at the next GTC. Thank you.